Hi there. Today on the bench we've got a Stromberg Carlson radio from the 1938 era. And just like most radios from the 1938 era, they need a little bit of help because they don't want to operate correctly anymore. And that's why it's here. We're going to bring it back to its former self and get it receiving signals and make somebody really happy again. So we can see it's in relatively nice shape. The cabinet's in really good condition, and the woodwork around the speaker here is all intact. And even the grill cloth underneath looks really, really nice. So this is a really nice radio to get working again. It really is quite a showstopper. I think it looks, according to my camera here, it looks quite a bit better in person than it does on the camera. It's a really neat radio. Now, Stromberg Carlson was a really interesting company. They really went above and beyond to make their radios just stand out above the rest. And this radio here, it goes continuously from the bottom end of the broadcast band, which is about 550 kilohertz, all the way up to 18 megahertz. So it'll receive the 160 meter band, amateur bands, and 80 meter amateur bands, and go right up to 18 megs. So really, that's about from 550 kilohertz to 1.7 megs in one band. In another band, it goes from the second one up, the red band, it goes from 1.7 megahertz to 5.6 megahertz. And then on the third band, which is the green one, that's just the one closest underneath the eye there, it goes from 5.6 megahertz all the way up to 18 megahertz. Now, most shortwave radios of this era, they only went from about 5.6 megahertz to about 16. So this one here really is quite extended. You can see on the top here, in this little bezel, it has a magic eye tube. And what a magic eye tube is it's a small cathode ray tube that glows green and displays when you're on frequency. And most of these tubes by now are pretty dead or very, very dim. And I'm hoping that this one here has a bit of life in it. If it doesn't, I'll just replace it. I've got lots and lots of vacuum tubes kicking around, and we'll make it glow nice and bright green again. So how they work is when you tune into a strong signal on a radio, the shadow angle changes and it kind of closes, makes a ring. And then when you go off frequency, it opens on the bottom, and you'll see that in the future here when I get this thing all up and running. I'll show you how that particular eye works. Now, another neat thing about Stromberg Carlson is they not only thought of the people that are going to own this radio, but they also thought of the servicemen too, which is a very interesting little feature. And when we go around the back, I'll explain exactly what I mean. Very, very interesting company. And what's even more interesting is Stromberg Carlson is still around today. That's pretty cool. So let's go into the back and check this all out and see what they've done and how they put this thing together and see how much work I have ahead of me. Okay, so here we are in the back of the radio, and we can see that somebody's already been in here and hacked around some wires, so I'll have to organize this and figure out what they've done there. One nice thing about this radio is that you can undo this plug here, and you can leave the speaker in the cabinet, so you don't need to drag the speaker, around with it. Unfortunately, for the amount of repair that I'm going to have to do to this thing, I will take the speaker out. It'll be sitting on the bench beside me here because, this is going to be a pretty extensive repair. So we can see here that the rectifier tube's over here. I already have the eye tube taken out. Before you slide the chassis out, you have to undo this little nut here and take the eye tube off, or it'll hit this inside. Now, what I mean of before when I said that they kind of look after the repairman and the person that bought the radio, they have handles on it here, so that the repairman can take it out and take it back to the shop with them, and when they're done, bring it back in. Even these little knobs here, so you can lift the back of the chassis up and slide it out. So very, very cool, the way that they design these things. You can see somebody's also added some caps and put some weird, funky cardboard spacers around it, and this one here too. So whether these are above the chassis potential, I have no idea, but the way it's put in, I wouldn't doubt it, so it's kind of scary. This looks kind of original. This is the rectifier tube over here for the high voltage supply, and right down in here there's 3 tubes. This would be the mixer and probably one RF amplifier and maybe an IF amp in the front. Don't really know, haven't looked at all of that yet. I've glanced over the schematic. I don't know where the tube placement is, but we'll find that out really quickly. This looks like an IF amplifier back here, and then there's the detector, a little 6H6 down there. This has got push-pull audio, so these 2 tubes are running in push-pull and driving the speaker, so it should have some really good sounding audio. So, in order to get the chassis out, what you do is you grab these 2 little knobs here, make sure our magic eye isn't going to go flopping onto the floor. Grab these and you just give it a bit of a lift. Of course, it's going to be a little bit fussy. You can see the handles here. They put handles on it. That's its only reason. Look at that. You can take this thing out and put it on the floor, which I'm going to do right now. So there it is, inside of the cabinet, dusty and dirty. Take it out into the garage and blow it out with a compressor and remove this speaker. You got to be very careful that when you're using a compressor, you probably want to take the speaker out and cover up the area so you don't damage the grill cloth. And you never want to put any kind of compressed air on the speaker unless it's quite a ways back, because you risk blowing holes in the paper or causing some other issues. So you got to be very careful when you're doing that, especially with these old radios. Everything's very brittle at this point. So that's where we are at this point. Here we have the top of the chassis. A little bit better shot here. You can kind of see what's going on a little bit easier. These are these horrible caps that they've put in with these cardboard collars. They're going to go. Pretty ugly stuff. I don't know who hacked those in, but that's and it almost wins the award for the ugliest hack I've ever seen. That's pretty bad. Look at that, just wound cardboard around it, and these are just sitting in there. You know, wouldn't doubt elevated above the chassis potential too. Yikes. So anyways, this here is the oscillator tube. This is the modulator tube, and the modulator tube also has a tuned grid, and it's hooked up to this particular part of the cap. And this tube here is a first RF, and it has also being tuned, as you can see here, by this cap. So what happens is when this receiver is receiving, as you move the dial around to different frequencies, it tries to keep everything in tune, and that way keeping the signals peaked up at all the time. So what happens is the signal comes in, goes in this tube here, and obviously goes into this tube here, and then this tube drives this first IF transformer. The signal comes out of this transformer, goes into this 6K7, comes out of that IF transformer, goes into this IF transformer, comes out of here, goes into this little tube down here, which is a 6H6, which is a detector, and then heads into these amplifier / phase inverter tubes, and then out into the 6F6s. And that's really how the whole receiver works. So this guy here is a high voltage rectifier. It's a 5U4. And what I'm going to do is I'm going to power this thing up without the tube in, remove the tube, and make sure that there's high voltage in the socket. And I'll also make sure all the tubes light up and everything, so that gives me verification that this transformer is still good. And I haven't tested the eye tube yet. We can see this is what the eye tube looks like. It's really dirty. This is a 6U5 or a 6G5, and it's pretty common. There's a whole bunch of different tubes in this particular design and style. You have the 6U5, the 6E5. You have a 6X6, I believe, is another one. Could be wrong. That's a really rare one. And then you have the 1629, which is one of these tubes. The difference between the 6U5 and the 6E5 is the gain. So one's a little more sensitive than the other, and one will react. The shadow will close with a little bit less signal. So that was kind of a thing that a lot of people did back in the day. If they wanted the shadow angle to close and it wasn't closing, they just sub it with the other tube, and you'd usually get more gain, or vice versa if they didn't want it to. But they're just a standard little cathode ray tube, and in the end I'll show you how that works. It just plugs into this little socket up on the top here, and of course it points out at the front of the radio as you're watching the dial. The dial is removed off the front of the radio and was cleaned up a little bit. The numbers are fading on that dial really bad, and it's got a spot from the sun. So, it's still salvageable. That was a really tedious clean job. I had to go between all the letters and the numbers and stuff so that I don't make it any worse. Turned out okay, but it is faded. So you got to be really careful with these dials when you take the dials off the front, that you don't wipe them too hard or use any strong chemical on it, because you wipe the numbers and the lettering right off. So don't ask me how I know that. I did that years ago to a Johnson Viking Ranger. It's a little transmitter, and they have water decals on them. And I took the dial out because it was dirty, and I immersed it in soapy water, and the whole dial came out. All the letters just floated off in the water, and you could just feel my heart drop. I'm like, oh no, I just completely destroyed this dial. So I had a sticker made. I have a Valiant, and I took the glass out of it. It's actually, well, it's a piece of plastic with these water decals on them, and brought it to a signage place, and they scanned it and they made me a sticker back in the day. So I saved it. I saved the dial, but it cost me an arm and a leg, and it was a really nice looking Ranger, so I did it. But anyways, lots of hard lessons learned, so we all do it every now and then. I didn't think they'd use water decals, but yeah, water decals they are. So if you have a Johnson, Viking, Ranger, or Valiant, or any of the Johnson line, do not put water on the inside of the dial. You'll be sorry. Anyways, this one here is printed on it. This is with an ink, but a lot more resilient, but still, you got to be very, very careful. So that's the rundown of the top of the chassis. So you can see this. There's electrolytics have been placed everywhere. This I think is an addition. This is original, and the ones that I replace this with will be originals, and they'll just be dummy caps. And I'll explain that again when I'm underneath the chassis and pointing around underneath there. So this requires a special kind of IF alignment, and we can see the IF. The tuning slugs are right here. So we'll move those in and out and tune the IF transformers appropriately. They want you to do it with a visual device, and that was called a wobulator. And that was used way back in the day to visually tune these. And basically it's a sweep generator and oscilloscope. And I have my my Hewlett-Packard up here, my HP Spectrum Analyzer. You see it up here, right here. I'll use this. It has a tracking generator output, and I'll align the IF with that. It can be done with a sweep generator too, and they have a way that's kind of the brute force way. You just do the peaking thing, and but you lose your you definitely lose the proper IF response curve if you do that. So it's kind of important to do that visually, especially with this one because it's it has narrow and wide IF responses, so you want to make sure that they look good. If the IF, when you peak them, you get really, really ugly looking curves, and it's not the way to do it really. So any IF is always swept, in any of my radios, even the little All-American 5s and AA6s. I even sweep those, so just to make the audio sound good, and it really does make a difference. It really does enhance the lows and all that kind of stuff, and make the receiver sound really good. So that'll be a process. I'll end up showing that too. So it's just one step at a time. So next we'll head under the chassis. Here we can see the underside of the radio. It's ugly, just like most point-to-point radios were back in the day. They did, they just pretty much put them together. And at any rate, all the caps look almost stock, except the Sangamo. It's been added, and they kind of just cut this and left it hanging here. So that paper cap must have shorted early on. So there's lots of paper caps in here. They're everywhere. So they're hiding here and under here and up in here. And I've got my job cut out for me working on this one. They're hiding in here, and where the coils are. There's one in there. I don't know if you can see that one. You can see it hiding out inside there. So Stromberg Carlson had a couple of neat parts here. This guy here has got 4 caps in it. There's 4 leads coming out of the top and 1 out of the bottom. So yeah, lots and lots of caps inside this one. I think there's 4.002s in here. And there's a couple of caps in this one here. So you can see, the technology was increasing even in these days here. They're starting to make things compact and putting everything all together. Those 2 caps you see on the upper chassis that had those horrible cardboard shells, it looked like what had happened is somebody had obviously wanted to replace the electrolytics because it was humming. So they pulled them forward and then just soldered the leads onto these new cans and put them back down. Because nothing in here looks like it's been tampered with. There is no room to get at those caps through here. You can see my finger is touching this, and then it's here, right? So there's just no room between the coil and here. So it's very tight. I can't get both fingers even in there. So I'm going to put some dummy caps on the top because these caps are just hideous. They look ugly with that shell there. Really hacky looking. So I'll put some dummy caps on the top that are era specific, and I'll have to remove this coil here, and that involves desoldering this entire switch all the way around, which is going to be a real pain, but it's got to be done. So I'll remove this whole coil assembly here and get in there and put new Nishikon VZs in there, and all the new capsule and resistors and stuff will be hiding on the underside here. So there's a lot of resistors in here that are probably okay, And what I'm going to do is test them all and make sure that they are, and the ones that are bad I'll end up replacing, and you know, the ones that are good I'll leave in there that are within tolerance, and it'll be run for a long period of time to make sure that there is no issues. See, there's the domino style cap micas in here, and there's this here, this guy right over here is another domino, and they're all over the place here. So yeah, you can't really see back under here, there's more of them under here. So this is the antenna tuning, and then this is the first RF tuning, and then this is the oscillator. So this all has to be tuned, and in a certain sequence, so that'll all get done, and it'll get an IF alignment. And I'll use the spectrum analyzer up on the top. It has a tracking generator in it, and they specify in the instructions that they want you to, at the factory, they used a visual device, which is obviously a wobulator or some form of a sweep generator back in the day. So I've got a spectrum analyzer with a tracking generator in it, and I'll just align it with that. So I'll get a nice response curve for the high fidelity, and for all the different IF settings that this has. So that is kind of important. They even mentioned in the instructions that they don't want you to align the IF if you don't have the proper tools, and they give you an alternative way, but it's really just a patch to make the thing work. You see there's a lot of really large resistors. These two guys look like they've been replaced. And there's another really, really big one up here. And you can't really see, it kind of goes into the chassis like this, but it's the same size as this guy. So there's a lot of really big heat dissipating components. There's a transformer here that's tar coated, and on the bottom that's another transformer that's tar coated down there. So I'm imagining one is the audio transformer and one is a choke, because the speaker doesn't have an output transformer on it. So one of these is obviously the output tranny, and I'm hoping that that transformer and that one up there, I'm hoping that they're both okay. Yeah, I haven't tested the power tranny on the bottom here yet. I haven't tested this guy, so I'll do that. I'll check it for B+, and I'll also make sure that the heaters are lighting up properly. And if that's good, then I'll move on to the next step. So that's where I am now. I'm not going to go into showing, you know, how I replace the caps. It's a long, time-consuming, tedious process. I don't just trim them out and then twist leads together. I desolder them right at the socket, and I have a tool for that, my Heiko 802 here. So I can get right in there. It has a remote pump that sits away from it, with the 470 pump, and I'll do it properly. I'll move it from the socket and from the chassis. I take them out the way that they were put in, and I don't necessarily tie to the same point. It depends on if there's one that's closer that'll work, I'll do that. The only reason that they tie to certain points is because the size of the capacitors back in the day. If they could tie them closer, they would, and I might just do that, and I just clean the thing up a little bit. So, a lot of people think that, the capacitors have got to be tied to the exact same point, or you get hum, or this, that, and the other. It's a lot of that isn't true. Just in really, really high gain audio stages and stuff like that, they have to be. RF, is the closer to the chassis you can get it, the shorter the leads on the capacitor, the better for RF decoupling. So, sometimes they have pretty long leads in here, so I'll use ceramic disc capacitors and bypass them directly right to the chassis as close as I can to the socket, and that just makes for more stable operation. Things like that, like things they didn't do back in the day, because they had to deal with the size of the components. They were all really physically big. Now we have capacitors that are surface mount capacitors that are the size of a piece of pepper. They couldn't make that stuff back in these days. So of course we're dealing with voltage ratings in here, so all the capacitors have to be at the correct voltage rating, and you can't, most surface mount parts are really low voltage, so you couldn't replace these even if you wanted to with surface mount stuff. I do have some 1206 surface mount stuff that's 500 volt rated, but that's kind of uncommon. So that's where I am at this point. When I have more to show you, I'll come back and show you some more. So now the entire radio has been recapped. We can see here all the caps that have been replaced. They're all over in here, everywhere. All these guys. These green fellas up in here, and this guy down here. These two little electrolytics here have been added. And all the electrolytics just take place of the cans that have been on top. So the cans on top are just dummies now. They just sit there and they kind of look pretty, but they don't do anything. All the caps are now under the chassis. See all the caps up in here, they've been replaced. There's some down in here. There's caps everywhere that have been replaced and resistors all over the place. Now you can't really make these radios look very pretty. As you can see, the wiring is just the way that they've wired it from the factory. Of course, I could, you know, completely loom everything, take the whole radio apart and rewire it, but that's kind of overkill. And the radio works just fine the way it is. See, so there's the new coax has been added that carries audio signal to the back. There's a jack that's been added on the back here. You can see on the back there is a jack that's been added. Looks to be by the factory because it's with a switch. And what's really odd is that they leave the receiver section working. The only thing it does is kind of, you know, open the audio up. And there's still a little bit of receiver bleed through, so the owner of the chassis or the radio will have to unhook the antenna line, and then it gets really silent after that point. So they may have intended that. That might have even been in the instructions for this chassis, I don't know. But there is quite a bit of bleed through. See, the receive section is so strong. And let's see, this section hasn't been tuned at all. This is the antenna, the RF, and the oscillator section. And this is the broadcast band here, and then another band and another band here. This is medium and high bands. None of that's been retuned, and the reason it hasn't been retuned is because that needs to be done with the bottom lid on. If you don't have the bottom lid on and you tune it the minute that you apply the bottom lid and put the bottom lid on, everything will move around. And reason being is because there is no shielding. This requires shielding around the coils in order to make things stay the way that they are. Of course, when you put a big metal aperture on the bottom, it affects the inductance of the coils, and it'll drag the oscillator around. It's not so important for these guys, but the oscillator section here is very important. They could have had a little, you know, thing over here. You could have tuned it with the bottom off, but once you get the IF tuned and everything done, it's kind of pointless. You may as well just do it with the bottom on. And there's holes in the bottom of the case that allow you to do that. You can see over in here the electrolytics have been replaced. There's two electrolytics, one here and one right here. These guys have been replaced with Nishikons, so there should be some good long life there. All the caps down here. And you can see these resistors here replaced that one that was mounted on the back here. And we can see here that this guy here, let's focus down here. You see this guy here was the one that was on the back. And we suspected that there's something wrong. You can kind of see a hot spot here, right? So when you turn it over, whoa, it's burnt right through. So if I can get some, it'll focus into that. A little bit too close. There we go. So you can see how bad that is. Just completely ate through the back side of that. And of course the wiring, and it's cracked it here, so you can just, you know, basically the thing will just fall right apart. So that's why there's this mark on the back of the radio here. You can see right here, if I can get the light there, that's kind of a mark on it, kind of like a burn on the chassis here, and that was right where that particular spot was. So what usually causes those resistors to go bad, or these guys here to go bad, is just leaky caps, and excessive current draw makes the resistor overheat. Now in this case it's a little bit different, and I don't know why Stromberg Carlson did this, and this might have been a flaw in their engineering, is they mounted the resistor to this screw here, and there was a screw down here that it mounted to, and you can see these pop rivets, they kind of stick up. So this resistor, if you remember earlier, was kind of bubbled in this area, and of course being bubbled in that area is not correctly, you know, heat sinking the backside of this resistor, you know, to the chassis. So by not doing that, the resistor got very, very hot. So that might have just been a flaw over time too, but of course now, you know, all the capacitors that I've removed are so horribly leaky you wouldn't be able to tell anyways. But I kind of think that that is a problem. It's supposed to sit flush on the chassis, and the chassis is supposed to sink the heat away. So these large porcelain guys are now replaced, and they stand off the chassis and they dissipate their heat in a better fashion. You know, like, I mean, this guy gets pretty warm, not super hot, but it gets warm, and this guy here just gets mildly warm. And that should you know, be very, very dependable for the future. You can see down here, there's a capacitor that's down here. Well, this capacitor actually, if we get the light down in here a little bit, you see it kind of goes to the center of these two resistors here. And these two resistors here had a wire that ran all the way up to the top of the chassis, ran all the way up, you know, in behind here and into a loom and up to this capacitor that's buried under here. So now, of course, with modern stuff, we have, let's lower the stand here a bit. With all the modern capacitors and stuff, you know, we can cram things into smaller spaces and so on and so forth. Well, this guy here, there's no reason for it to be up at the other end of the chassis, and that just, of course, you know, adds problems. So we can put this right next to where it's supposed to be. These resistors don't get hot at all, and of course this cap is rated at 105, so it's completely fine here, and it's grounded directly to the chassis here. And so it's right next to where it needs to be, so we can eliminate a very, very long piece of wire. This wire here, you know, completely eliminate that whole piece of wire, and that's, you know, a really long chunk of wire. And of course, just eliminating more problems. This capacitor here was also up in here because of space restrictions. The old capacitor was a really large device. The new ones are really small, and the voltages are higher too. So I could mount it right to this little tie strip right here. That capacitor was right across here, which goes right across the inductor. You can see on the bottom it has a brand new line cord here. Get the light up in here. It has a brand new line cord here, and this is a heat resistance pipe. This is a flame retardant pipe. It doesn't burn. And anyways, what happens is the line cord runs right into here. There are no breaks in this line cord. It just runs right through this heat pipe all the way over into here and right directly to a fuse. So there are no tie points in the hot line. The first thing that's in line is this low amperage fuse. And what that does is that eliminates a lot of problems. A lot of times people run them to the tie strip because this is where it was supposed to go. The line cord went to here and to here. So there's nothing on this terminal now, and it's just used as a post to hold this wire. And what happens is there's this long wire that runs all the way around here and to here, and by doing that, there's nothing else in line with the hot lead. So the very first thing in the radio that's in line is the fuse. So if anything goes wrong, you know, it's instantly gone. It's a really low current fuse, just above what the radio draws to be very, very safe. Now, what comes out of the fuse goes directly into the switch and then, of course, back into the transformer again. And this is the hot line that runs to this particular side of the fuse. And the other side of the line cord is the neutral, which goes to this terminal tie strip, which is isolated from everything, and then runs directly into the transformer. So it's very safe. It's a polarized plug, so that it always keeps the neutral side on this side, and it always keeps the fused lead hot, or the hot lead is always the fused lead. So it's a very safe thing to do. I suggest anybody that works on these kind of radios to install a fuse in line, whether it's just in a fuse holder or whether it's like this one. This one is actually mounted to the chassis, so it's very easily replaceable. You just pop it out and put a new one in. Now, again, this fuse should never go bad. If something really goes haywire in this radio, this fuse is going to blow, which means if this fuse is shot, there is something wrong with the radio. So either the rectifier tube has shorted, or there's a short filament lead, or the power tranny's got an issue, or something like that. So that's what that's there for. It's there to protect the radio from really self-destructing, and there to protect the owner from anything that might happen with a radio that doesn't have a fuse. Now, none of these radios were issued with fuses from the factory. And what that means is that when something went haywire, usually the transformer just burned out, and that's why it's in a complete shell. Like the whole transformer is completely shielded. And anything that could go wrong in this chassis is completely covered in metal. There's a metal case that goes over the bottom of this. So if anything was to ever go wrong in here, it's completely shielded inside a metal box. So it's a very, very safe radio, and Stromberg Carlson was always really strong on that. So anything that's would go wrong is held within the box. So it's extremely safe and virtually eliminates any possibility of a fire or anything like that, which is a nice little feature. I always like that. A lot of the cheaper radios, they had an open bottom just like this, and it bolted right to the wood, and that was always scary. Sometimes they put an asbestos mat under here in some of the older radios. You'll probably note that, and they did that to cheap out so that they wouldn't have to put a metal cover on the bottom. So this one here has a metal cover on the bottom, and that greatly enhances the safety factor and everything. As I said earlier, they really made this repairman friendly, and they put a lot of thought into this. Like even these metal strips here that bolt, they're grommeted. There's actually like shock mounts, like shock absorber rubber grommets in there, and they're still, you know, perfect. And you know, for vibration's sake, a lot of thought from, you know, the engineers really went into this. Again, the one thing they overlooked, I think, was this resistor. But all 240H chassis, I imagine, are probably just like this, or all the Stromberg Carlson radios from this era are like this, or have a problem with this resistor. It's two separate resistors. There's no join here. This is one resistor here, which is 1.9K, and there's one resistor here, which is 22 ohms. And there's no connection between the two. So this is one separate resistor and another separate resistor. So if you're working on the chassis and you need to know those values, there they are. There's a PDF online, a whole entire service manual really for this radio online available, and that's quite a nice thing to find. It was in PDF form, so makes servicing a little easier. When I go through a radio like this and I do service a radio like this, I always take notes. I measure the inductors, I measure the filter reactors, and I also measure the output transformers and all that stuff and everything, and mark all the stuff that's not on the schematic down. And that way, if I ever come across a chassis like this, which I have before, you know, I have all the ratings and everything. I also mark down what's inside the IF cans on the top, and I've removed both IF cans and been inside and checked the resistors. There's a resistor in this IF can, a 47K resistor, and this guy here is just a bunch of caps. That's it. Nothing paper. There's no paper caps or anything inside these cans, so you don't really have to remove the IF cans in the 240H chassis unless that 47K resistor's gone, or if you have a problem with silver mica disease. This guy here is for tuning the low portion of the broadcast band. Back here is a wave trap. This is the wave trap back in here. These two terminals here, I purposely made these ground, and you can see like this one here is right in line with the with this little variable capacitor here. And now the reason that I made these ground is so it's safe to run the screwdriver into here, and that way you don't have to worry about touching anything. It's very safe. This guy here is just an attenuator, as I explained before, for the broadcast band. That is only operates on the broadcast band and nothing else. And I think that's pretty much it for the bottom side. I think I've pretty much hit everything on the nose. So there we go. Here's the IF response of this old Stromberg Carlson. So this is taking quite a while to get this response pattern because the IF transformers in this thing were really screwdrivered, and the peak was sitting over here, which means that it's way off frequency. Right at the center of the screen is 465, and that's the center IF of this particular receiver. If you move the slugs the wrong way, it'll pull the center off either way, and you know, you get your response pattern way over here, and it's kind of pulled to one side. So now the response pattern of this receiver isn't all that incredibly pretty, and you know, for its date 1938, I don't really expect it to be, but it's not bad. On the tight response pattern here, it looks really good, and on the mid one, it's not too bad. That's the medium fidelity right there. It's pretty good, pretty wide, and it's the wide fidelity is just crazy wide, and you really can tell because I've listened to some high fidelity broadcast through this, and it really is quite high fidelity. It sounds really, really nice through this receiver. So the alignment procedure is kind of straightforward. The 6A8 on the top is what they call the modulator, or basically it's just acting as a mixer. So if I put this here, you can see where it says cap in loose. That's the 6A8 tube right there. And what I've done is I've clipped the tracking generator through a little box that I've built. I've built a couple of little boxes I'll show you in maybe at the end of this video here. Through a box I built to that, and what it does, the box kind of just well, keeps the levels down a little bit and also protects the input and the output of my spectrum analyzer. But at any rate, it says there cap in loose. You can see that. So that's the cap of the 6A8. That's where the signal from the tracking gen is going in. And it's just clipped to the insulation of the wire. It's not even clipped right onto the metal cap of the tube because there's too much signal there. So it's just using that. And then, if I move this over a little bit here, you can see where it says out loose. It's the same thing. There's another one of those little boxes connected to the plate of that 6H6 tube but it's just close to it. There's a .001 mic cap right here, and or 1000 pico, however you want to call it. And that cap, or the little test lead, is just wedged in there to pick the signal up coming out. If you couple to this, it'll pull the response pattern off, and also if you feed this with too much signal, it'll also drag the response pattern. So it's a little bit of an art to try and get it just perfect, because you want to make the receiver think that there really is no tracking generator and no spectrum analyzer or anything hooked up to it. So, and that's kind of really the trick. And once you get that down, then you'll get some really nice sound out of these old receivers. If you couple them hard, it really will drag the pattern and make an ugly pattern. So I've got it hooked up here to show you. Maybe I'll show you what actually directly connecting it. And that's through a really low coupling cap. Like we're talking 13 picofarad will drag this, because the you know, on the detector tube, because it's so sensitive. At any rate, I'll get into explaining how I've actually tuned this here. There's 4 slugs in these IF transformers that you have to tune, and you work your way around, and you get to feel which particular slug affects what and how it moves the response pattern around. And again, that's just a feel. If you ever fool with one of these things and you have a tracking generator or a sweep generator, you'll understand that at that point. You'll find that one slug will really pull the center frequency off. That's usually the first one. And then the end, well, you know, it'll kind of drag it, you know, drag the whole pattern around on the screen. And a lot of the times it will actually, you know, widen and shorten the response pattern here. So how we do this now is we want to find out how wide this actually is, and that's a pretty simple thing to do. So we're on the narrow one right now. As we know, this is the medium fidelity and this is the high fidelity setting. So we'll go back here and we'll figure out how wide this first one is. So what we're going to do is, I've got a baseline down here. I'll turn on the baseline. It's called a display line. I can move this around. And what I'm going to do is, we want to figure out the 3 dB points here, and we'll calculate it from that. Okay? So I'd say right about there is the top of the line. So it's 34.5 dB is where the line is sitting there. These are 10 dB per division, or per box here. So what we're going to do is roll that down to 37.5, and that gives us 3 dB. So there we see 37.5. So that's 3 dB right from the top to that particular point on the line. So I'll turn my marker on, and I'll move the marker over. Say right about there is at the line, or right on the line. So we got 463,160 from the center frequency, which is 465. So what we do is we take that away, 465, take away 463.160, which equals 1.84 kcs, or kilohertz, on one side. So we times that by 2 to get the full width from this side to over to this side over here. And I'll just put that right down there again, to not be confusing. Okay, and we times that by 2, which gives us a 3.64, or sorry, a 3.68, or we could just call it 3.7. So it's about 3.7 kcs wide is our narrow, or our first response pattern. So that's pretty narrow, you know, 3.7, almost 4 kcs wide. That's going to, you know, keep adjacent frequencies, you know, a little bit at bay. You know, with these old receivers, it's hard to do that single conversion and everything, but it'll narrow things up, and it'll also be good for shortwave too. So we can say 3.7 kcs, or, you know, 4 kcs wide, something like that, is the first response pattern. So, and we do the same thing to find out the second one. So we know that the first one, will mark that down, say 3.7. So here's the second one. So of course, we're going to move the marker back into the center here again. So there's 465 right there. So now we want to turn on the line here, and we'll say right about there. So we're trying to get it center with about the center, right at the center of the screen. We're not worried about here, because sometimes they'll peek up on the sides just a little bit, depending on the IF trannies and how they've been designed. So that's about right. 36 is about right on there, okay? So 36 is our reference point. That's the only thing we're doing here, is just using that as a reference point. So we want, obviously, 39. So there we go. Now we're at 39, so what I do is I turn on my marker again, roll that over to this one side. Say about right there is on the line. So 459.360. So we take 459, or we take 465, I should say, first, and take away 459.360, which will give us 5.64 kilohertz one way, or kcs one way. So we times that by 2, we get 11.28, or we can call it 11.3 kcs wide, or 11.3 kilohertz wide. So we call that 11.3 kcs wide from side to side. It's pretty balanced, so I'm just taking this. You know, we could really get accurate and calculate this side here and see how much it actually is per side, but that's close enough. So we're about 11.3 kcs wide. That's pretty wide for the middle. So that's the medium bandwidth, and it does sound really good on just the medium alone. And then we have the barn door setting, which is this guy right here, which is, you know, wide open. It's like I don't know. It's extremely wide. So we'll center this up here again. Okay, and we'll move the display line around. Say about -40. It's right about right where it is. Right on that graticule line right there, okay? So again, this is just a reference. This is just a reference line. So obviously we're going to want -43, right? So there we go. So pretty balanced. As close as it's going to get. That's the way these IF trannies work. So now we'll move the marker over here. I'd say right about there. 450. Oh, that's right. Right about there. I think I bumped it. 456,520. That looks about right. So 456,520 is one side, you know, from the center. So we take 465, take away 456.520, gives us 8.48 kcs one way, or kilohertz one way. So we times that by 2, and we get 16.96, or we can comfortably call it 17 kcs wide. So that's a pretty incredibly wide response pattern. So that's the barn door setting. That's really hi-fi listening. You know, we're talking your own kind of home broadcaster that you've built on an empty frequency, and it's sounding pretty good at that, you know, at that width. 17 kcs wide is absolutely crazy. So that's about as high fidelity as you're going to get. In fact, this is actually one of the widest IF transformers I think I've seen. So, of course, the response pattern isn't completely flat. If you're working on something like a Hammerland SP600, or you're going to, you know, work on a receiver of that particular caliber, you'll see, you know, pretty flat. Sometimes a bit of a dip depending on you know, how it's tuned and everything and all that. But it's you know, this is actually pretty good. It's not flat, but you know, it's got a little rise here. But you know, pretty much, you know, it's doing pretty good. The 3 dB down points are doing a-okay. So that's the response pattern, medium and wide. And actually, this is narrow, I should say. So this is narrow here, and then of course we have our medium and our wide right here. And that's how you calculate your width of your IF section. It's a pretty easy thing to do when you have a spectrum analyzer or anything like that. So next I'll be tuning the RF and the oscillators and the antenna section in this thing, and I'll maybe run through that too. So that's the IF tuning. I'd like to show you right from nothing how it's tuned, but actually it's a really timely procedure, just getting this response pattern in here and correcting where the receiver actually was is about a good half hour, 45 minutes of balancing. They want you to tune it between this, and that's alone. So right there from here, they just say, oh, make it look the best that it is here, or tune for the best response pattern here. But if you just do that and you completely ignore this one here looks absolutely horrible. It's really crazy. So you kind of have to go between the two. So you tune this one, get it looking good, and then you go to here and then you retune the trannies and make this one look good. You go back and then this one's off again. So you recenter the frequency and then go back to this one, and this one's haywire. So you fix this one and you kind of work back and forth between this one and 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 this one until your eyeballs are ready to fall out. And then you finally get it right. And then when you go to the wide one, it's looking pretty good. You check the wide one every now and then too. And it really is a balance just to try and get the best looking response pattern. So again, it is the labor of love. And you can really understand how just peaking the IF section in any old receiver really, without a visual device, isn't good enough if you're really looking for any kind of fidelity, or trying to keep the distortion out of it, or just wanting to have a really good sound. Peaking works, if you don't have the test gear. You can use the oscilloscope method and just peak the thing up. But this is the best way. You get the center frequency right on. You can see it's right at the center. And if it wasn't, this hump would move over here or move over here, and then of course your IF center frequency's off. So it really is important to have some form of a visual device. So even getting just a sweep generator and an oscilloscope and learning how to use that with tuning your old receivers is a great help over just using the oscilloscope, peaking method, or likewise method without any kind of a visual device that's actually looking at the pattern. Hi there. So what we're going to do is align the broadcast band on this radio using a signal generator up here, and using the alignment trimmers here. There's a alignment capacitor under here, and then there's an RF and an antenna guy at the end here. So what we're going to do is align it. This has to be handheld because there's a lot of movement here. So in the instructions, they want us to align this at 1.5 megs. So what we do is we turn the dial to 1.5 megs, right about there. Okay. So that's 1.5 megs. Now we enter 1.5 megs in the signal gen here. So you go 1.5 megahertz. Okay. And we have a tone. We have a 1 kilohertz tone at 74% mod. Doesn't need to be anything like that. I could make it 75 to be even. It's just where I guess the dial happened to stop. So anywhere in there, 50%, as long as you hear a tone. All right. And I've got about 36 microvolts coming out right now, and it's going through a 400 ohm resistor and into the back, and with the appropriate connections. You also want a cap there. So now what I do is I go to here, which is the alignment hole, stick my insulated screwdriver in there and turn this until I hear a tone, and that'll align the top end of the dial. Okay, now you can use the eye. When the eye is at its maximum, you can see when it closes to just about as far as it'll close, you're right on frequency. So right about there. So you can see when we move off the dial. So that aligns the top end of the dial. So now we need to go down to 600 kilohertz to align the low end of the dial. And we'll have to go back and sanity check again, because when you drag the bottom end, it drags the top a little bit. And you kind of have to go back and forth a couple of times. So what we'll do now is we'll go up to here, and we'll put this at 0.6 megahertz, which is 600 kilohertz, okay. So now we come down here, and we roll the dial. See how far off that is? That should be right here. Okay, so that's 600 there. So now what we have to do is they call this a series aligner, and it's in this hole here. I'll back up so you can get an idea of where it is. It's down through this hole. Now this series aligner has two nuts on it. It has one for the B band, and it also has one for the A band. The B band is the outer nut. It's a 1/4 inch nut on the outside, and in the center it's just a small screwdriver kind of slug. I'll see if I can get my flashlight in there. It's not going to be too bright. You can kind of see inside there, the outer nut that you see on the outside aligns the B band, and the inner screw aligns the low end of the A band, which is what we're on right now. So I have to feed my screwdriver in here. It's insulated, as you can see, doubly insulated with tape and everything, and I just have to get it in there, and we turn this until we hear a tone at 600, and that drags the bottom end of the band. I think my screwdriver came out here. There we go. Okay. So there we go. Again, we use the eye. So there we go. We're at 600 now. So now what we're going to do is go back up to 1500 and see if it pulled it off. So what we do is we go back up here, 1.5 megahertz, and then we roll the dial back up. A little bit. So what we'll do is we'll adjust this again. So you got to go back into this slot here, which is up here, which adjusts this part. Now it's important to be as accurate with this as you can, because your dial accuracy really relies upon this. You got to remember this is an analog dial, so it has to track. You know, some guy spent a lot of time at the Stromberg Carlson factory marking all these little lines in here, and with their finished product in making the dial, that's why you see there's some larger spaces and some shorter spaces, because it's, you know, not exactly even throughout. So now what we do is we go back down to 600 again. There we're at 600, okay. We'll go back up here to the signal generator and hit 0.6 megahertz. Look at that, we're right on now. So that's pretty good. Yep, right on the nose. So just for accuracy's sake, a lot of these dials, they don't track incredibly accurate, because, you know, the thing's 70 years old. But we'll try 1 megahertz and we'll see how well 1 megahertz lines up. That's about the center of the dial. So we'll go 1 megahertz, and we'll come back down here and we'll rotate the dial until we come to 1. That's pretty good. It's very close. That is actually quite impressive. And that's how you align this. Now, of course, they want you to peak the entire thing up at 1500. So you have to peak the RF section up and the antenna section up. And so what we'll do is we'll go back up to 1.5 megahertz. Okay. And we'll just peak this all up now. So I'll go into the second hole here because we're working our way back. Get that in there. And we use the eye. That's just the screw on the capacitor moving a bit. Right about there. So that's the second one back. Now we go do the antenna one, which is the third one back, which is right here. And you see how much that's changed. There's a lot more sensitivity now. And that's the importance of aligning the bands. So you can really see how much more movement there is in that eye right now. So it's very sensitive up there. And that's the importance of doing an actual alignment. And the IF, of course, has the same effect. If the IF is out to lunch on one of these receivers, they not only sound bad, but the dial won't even line up. If the IF frequency is out, it throws the actual dial accuracy out too. So that's why it's so important to have your IF frequency correct. if I was to say, you know, if I didn't have a schematic and I thought that these particular coils were supposed to be at 455, I'll just tune that off frequency. If they were supposed to be at 455, this dial accuracy would be right out to lunch. You'd never get it to line up. So that's it's very important to have the IF centered properly. So there's 1.5. So let's go back to 600 and just do one more sanity check, because we adjusted the other sections there, just to make sure it didn't drag the oscillator at all. So here we are. I hope this isn't too shaky. Sorry about the shakiness. This has to be done by hand. That's right on the nose. So there we go. And that's how you align a receiver. And it goes the same for this band here and the upper band. I've done these two bands already, so I don't need to go through and do them again. They want you to start at the top and work your way down on this one. And that's what's been done. And that's how you align it. They have the alignment for the top end of the band. They have a thing called a series aligner, which is the bottom end of the band. You have to align them both to make the band track correctly. So there you have it. Here's the Stromberg Carlson put back together. I've got a bright light shining on it right now just to light up the wood. You can see that bright desk lamp there. Now you see how bright that tuning eye is. That's how bright they look when they're brand spanking new. So if you have a radio with a tuning eye and it's not that green, then you know that it's probably getting tired. Keep in mind that's a bright light shining straight on it, and you can still see how nice and green that green eye is. So I'm going to give you an example of how well this receiver works when it's been repaired. So of course this involves, you know, retuning the antenna and the RF section, you know, realigning the oscillator and going through and doing a proper alignment on the IF. And you do end up with a really, really nice receiver in the end. And I'll just demonstrate that right now, how well this thing receives. So I'll take my wide angle lens off here and focus into the dial. Alright, so you can see that there's kind of a white pointer in behind here. It's just kind of a little slit of light, and then the whole dial moves in front of that. So I'll turn the lamp off. It makes the dial a little bit easier to see. Alright, so I'll turn the volume up and I'll cruise the broadcast band, and you can see how well it actually receives. So here we go. We're right at the top end now, so here we go.
And one other thing that...
And that means it's not.
25 to 4 up in Boston. Yeah, but so they didn't get to go. I'll hold you about. Come on. They're real.
And there ain't no sugar.
Our service for only $10 more a month for
Seems like a really
Family.
I see. I can pull already. Because our makes his way out of the
And as
Doug old scores on the up as he continued to camp.
only applies if you live here.
You want to watch something? Go to a movie. Yeah, there's often. Because they never make
Take this as just a repeating. Do you have any updates for us or see anything?
no one else.
I think that it's time to
And one of the places where. Well, now he's picked it up. Throws the love.
You know, this $9. If you don't have time to go there.
We do those things, then we become a child of God. It's a mystery.
So you can see how very sensitive this is. So that's at the tight bandwidth mark. That's narrow bandwidth.
Who's listening today?
So this is with the bandwidth at the
To
10
receive
kc.
Christ, believe in Him, and that's where.
If you remember, we tuned it. That was the mid position.
Again, I mean, that one.
We got feed here this year. Property.
Hey, Mike Salk here, the Brockens.
Mushroom supplement.
He's getting a good biome.
Listen, Gary Dietrich.
Yeah, nice and clean that sounds.
Time. So they
Education. Click.
I go in. Really curious to see. Bank record.
The crowd just must be going.
2 to 3.
Davis.
So you can hear how nice and clear that is. And this is hooked up to a long wire antenna, just like these radio receivers were intended to. And this long wire is actually cut for my ham radio band that I talk on, which is on the 80 meter band. So any of you that have ever fooled with one of these old receivers know how they work up at the top. Usually they get pretty deaf, right up around the 18 megahertz mark. So what I'll do is I'll move the band right up to the top band, and I'll show you how well this radio performs right at the top end of the band. And this is even hooked to an 80 meter dipole, so it's completely non-resonant at that point. Look at the strength of that signal up there. That's right at 18 megahertz. Now keep in mind, this band really isn't even in right now.
11 al 21 de septiembre de 2000. Como la primera edición, la estatura.
That's using a fine-tuning control in the center. There's a gear reduction drive on the front of this, so you can really narrow into those little frequencies that are kind of hiding between each other. And of course we have this on the 10kc. If we move this down to here, that'll help us out quite a bit. Separate the frequencies. There's lots of them I'm zipping past there. There's the 10 megahertz signal. So that's how this receiver works. I'd show you the 80 meter band, but there's just some sideband action on there right now. And this doesn't really receive sideband. It'll receive it, but it doesn't have a BFO to make it sound properly. So sideband is a suppressed carrier, and this needs the BFO to insert the part that's missing. And this does not have a BFO in it. So that's what sideband sounds like. Now if I couple a signal generator to the input and go onto the frequency that these guys are talking, it will completely decode them. So if you have a small signal generator kicking around at your place and you have an old radio like this and you want to receive sideband, all you have to do is just hook that signal generator with a low-level signal up to the input and mimic the frequency they're on, and they'll come right in. You can hear how it just kind of sounds like wah wah wah. That's sideband. And that's pretty much it. So I hope you enjoyed this rundown of this old Stromberg Carlson and the repair. And this kind of just gives you an idea of how well one of these old receivers really works when it's restored. They're quite impressive, and they're really, really nice band cruisers. So if you like listening to the broadcast band and you enjoy listening to high fidelity broadcast, during the day when there's not such a pile up on the band, it's much easier listening, because there's actually, you're not listening to bands and frequencies come in from all over North America like we are right now. They're even coming in from Mexico on the broadcast band. So during the day, it's usually only your local stations you hear, and if you have some really nice classical music stations or anything like that around, a receiver like this really is a cool thing to have, because you really get to enjoy that classical music, and it sounds very, very nice. We have a classic station up here, and when I tune into it with this on its wide bandwidth during the day, it sounds really, really well. Now, if I go right, to the barn door setting, which was the 17 kC wide, there's a frequency that's really close, and I get a little bit of a whistle or a hiss in there because it's kind of bleeding over into it. But on the middle, where it's the 10 kC, it's not too bad. And then, of course, on the tight bandwidth, which was the 4 kCs wide, it sounds just fine. But, of course, you lose your fidelity down there. So that's the rundown on this receiver. Hope you enjoyed. See you next time.